Hello, welcome back to Alien Space Talk. My name's Andy, and today's talk is all about Venus. We're taking a deep dive look into it in a longer version. I hope you enjoy, and we're going to get straight into it. As we already know, Venus is the second planet from the Sun. It's our closest planetary neighbour. It's similar size and mass to Earth, earning its title as Earth's sister planet. So we think of it as our sister. But it's where's the similarities end? Venus is a world of extremes, a place where conditions are so harsh that it's often referred to as the hell planet. You don't want to go there. It's hot, it's dangerous, and I'm going to explain why. Let's start off with its atmosphere. Think of the Earth's atmosphere. It's nice, it's nitrogen, it's oxygen. We can breathe it. Venus's atmosphere composes of 96.5 carbon dioxide with traces amounts of nitrogen and other gases. We can't breathe carbon dioxide. It's dangerous. It's horrible. Ugh. Its thick atmosphere creates an incredible strong greenhouse effect, trapping heat, and causes the surface temperature to soar to around 465 degrees Celsius or 900 degrees Fahrenheit. That is extremely hot, extremely dangerous. And as you know, Earth, we're having a problem with greenhouse gases. It's causing a hole in the ozone layer, and the greenhouse gases are getting thicker, so our temperatures are rising, so we're getting hotter summers and colder winters. This is what's happening on Venus, but we're only getting hotter and hotter and hotter. So to put this in perspective, that is hotter than the surface of Mercury, even though Venus is twice the distance from the Sun. Trapped in so much heat, it's even hotter than Mercury, and it's right next to the Sun. The heat is so intense that lead and zinc and other types of metal alloys will melt. This extreme heat also means that there is no liquid water on Venus. Any water may have existed in the past have long since evaporated and been broken down by the Sun's ultraviolet radiation. Okay, so the ultraviolet light is getting through. It is getting hotter. The sun is heating it, but the atmosphere is so thick, it's trapping it all inside. So the heat can't escape. Like this, we have clouds, and the sunlight can escape past the clouds. This heat is trapped inside. It can't break through. So it's getting hotter and hotter and hotter. So any water there is evaporated. Remember, water boils at 100 degrees Celsius. This is 465 degrees C. It's gone. It's not there. It ain't going to exist. So we have to keep an eye on it. We have to see what's going on to help us understand, to make sure we keep our water safe, so we don't want it to melt or boil away. High temperatures on Venus are accompanied by crushing atmospheric pressure. The pressure on the surface is about 92 times that of Earth, equivalent to being nearly 3,000 feet underwater. Now, remember what I said about our ozone layer and greenhouse gases getting trapped? We know that our polar ice caps are melting. If they keep melting, we will be underwater. But imagine being 3,000 feet underwater at the bottom of the ocean. All that weight, all that pressure on you, you'd be crushed. You wouldn't survive. It wouldn't be nice. It'd be very, very, very hot. And plus, at the very bottom, it's very, very cold because the light can't get through to heat us up. So we need to stop the process. So by studying Venus and understanding how it happened, we can make sure it doesn't happen to us. It's very, very important. The intense pressure has significant implications for any spacecraft which might land on Venus, as they must be built to withstand the extreme conditions, which is no easy feat. Think about a submarine. It's underwater. It takes extreme pressure to stop it from getting crushed. But it doesn't go down 3,000 feet. We need to get down to 3,000 feet. And we need submarines to be able to survive that. And then we need to figure out how to get that to Venus and land it without it crashing. That's a big, big task. Maybe you can help figure it out for us, and make sure we can do it safely. Remember, it's also got to understand the atmospheres and everything like that. One of the most interesting aspects of Venus is its rotation. Venus is known to have a retrograde rotation. This means that it spins in the opposite direction to most of the planets in our solar system. And if we were standing on the surface of Venus, it would mean we'd see the sunrise in the west and set in the east. So it's spinning backwards, which is not normal. For some reason, we don't know why, but it is spinning backwards. So we'd see everything in reverse. And its slow rotation means a single day, which on Earth is 24 hours, takes 243 days. Hang on, that's 24 hours for Earth to rotate once. It takes 243 days for Venus to rotate once backwards. That is very, very slow. Which means its day is longer than its year. Its year, because it's closer to the sun, so the time it takes to orbit the sun, is 225 days. Yet it takes 243 days, Earth days, to have one day. So its day is longer than its year. That is really, really strange and really, really weird, and we need to study it to understand why. This slow rotation combined with a thick atmosphere creates an unusual dynamic where the atmosphere circulates much faster than the planet itself. The phenomenon is a superrotation. So the surface is going really, really slow. But the clouds, the wind, they're spinning super, super fast. So it's not going to be nice. So it's something we need to look at and understand better. We're not sure on everything, but we're still studying it. What we do know is beneath the thick atmosphere lies a rocky, volcanic surface. Radar images, particularly from NASA's Magellan mission back in the early 1990s, has given us a detailed view of the surface, noticed by X-ray, remember, by radar imaging, which dominated the vast plains covered by lava flows. So there's a lot of lava flow and a lot of volcanic activity. Mountain ranges, numerous volcanoes are still active. Some of these volcanoes are massive, with Mat Mons being the tallest, approximately 8 kilometers or 5 miles high. That's really, really tall. Can you name in the comments what is our highest mountain, and is that the same size, or is there another mountain that's closer? There are ongoing debates whether Venus is still volcanically active today. We don't know because we can't see. We need radars imaging to look at that, but we also need to go there and actually have a look through the clouds, but the clouds we can't get through yet. Some data suggest there still may be some active, which would mean that Venus is one of the few places in solar activity that still has active geological processes, which means that just like Earth, our tectonic plates are still shifting, so we get earthquakes, we get tsunamis, we get volcanoes going off. Venus may still be doing the same thing, but it has other water, so it'd be earthquakes and volcanic activity. We know it is still moving. We do know it's rotating slowly, but what's happening on the surface, we still need to understand better, and we need to get there better. But because it's so dangerous, we still need to learn a lot. In addition to its volcanoes, Venus's surface features large regions of deformed terrain, known as tesserae. These are some of the most geological, complex and oldest parts of the planet. The terraces are known to be formed by intense tectonic forces, but unlike Earth, Venus does not have tectonic plates in the way we understand them. Instead, the planet's crust is thought to be one of a solid plate that periodically undergoes resurface events, whereas the entire surface is reshaped by volcanic activity. So we don't think it's got tectonic plates, very similar to them, but we think it's one big tectonic plate, and occasionally the pressure underneath will just form it to burst and the whole surface will change with big eruptions for volcanoes. And obviously that lava will dry and create new terrain, everything like that, but the volcanoes will also change shapes or spew lava in different directions. We don't know, but we'll try and figure it out. That's what we think. We may be wrong. It could be just like Earth, but we're trying to understand it. Now, the atmosphere, as I said, is not the same as Earth. The atmosphere and the weather patterns has thick clouds of sulfuric acid. That's not nice. That's not nice at all. That melts your skin if that touches your skin. No, 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 no. We don't want that. That enveloped the planet and reflects about 75% of the sunlight that hits 75 of the sunlight that hits Venus. So it's reflecting 75% back, but 25% gets through. Excuse me. Making it one of the brightest objects in our sky, second only to the moon. So Venus is a really, really, really bright star-like object in the thing. And if you see it, you'll see it it'd be just like a star, but it's really, really bright like a star. But it's the Venus planet. Okay, so when you see it, you'll know it. It looks a little bit bigger, depending on where you are. Okay. The clouds create a dynamic, harsh environment with powerful winds that can reach up to 360 kilometers per hour or 224 miles per hour. Super fast, super dangerous winds blowing really, really fast, which help the lava flow. Obviously cool, but it's sulfuric acid in it. Not so good. While it doesn't rain water on Venus, it does experience acid rain, where sulfuric acid droplets fall through even though they evaporate before they reach the surface due to the high temperatures. So sulfuric acid does fall, but it's in the wind. So you think about when you go out in the rain and it's really, really windy, you feel the rain against your face. Well, that's what's happened with the sulfuric acid. Yet because it's so hot, before it reaches the ground, it's evaporated. And it's gone back into mist and gone back up into the sky. So it's constantly circulating, just like our rain does, but it doesn't touch the ground. It evaporates before it reaches there. A study of Venus is crucial for understanding the phenomena of the greenhouse effects and its potential impacts on Earth. So we are studying Venus to help us understand how not to become Venus. Basically, we've got to keep us safe. We want to stay alive. We've got to study Venus to make sure we don't destroy the Venus. We don't destroy Earth the way Venus is. Venus is considered a cautionary tale of what would happen when the planet's atmosphere traps in too much heat. By studying Venus, science can better understand the dynamics of climate change, not just Venus, but also on Earth and other planets with atmosphere. So we're trying to make sure that not only where we are, we're safe by making sure we don't end up like Venus, but if Venus has a thick cloud cover, it's got sulfuric acid and it's trapping the heat in, it's getting really, really hot, we know what's on the surface. Are those planets safe for us to visit? No. But by studying them, we understand them, and they can help us better understand what the Earth is like and how to prevent us from melting the polar ice caps, becoming underwater species, helping us stay alive better. So it's really important we do carry on our studies. Venus has been a target of numerous missions over the years, starting with the Soviet Union, the Venera program, which included the first spacecraft to successfully land on Venus. These missions provide a first direct data from the planet's surface that show a rocky, desert landscape with no sign of life. Most recent NASA Mangler mission used radar to map the planet's surface in detail, revealing a complex geology of Venus. Now remember, the Soviet Union's mission was in 1970. NASA's Mangler mission was in 1990s. 20 years apart, and we haven't been back since, and we're now in 2024. So we've got to keep looking. We've still got to do more. We have launched that there are several missions to go back to Venus. Vetrus and Da Vinci Plus, launched in the late 2020s, aim to study Venus's geological and atmosphere in unprecedented details. So we're going back to understand them better, to make sure we do better. The European Space Agency's Envision mission is also planned to study the planet's surface and subsurface. So we're going to start looking at what's underneath. We know what the crust is like because we can see the lava, we've seen that, but what's underneath that? Is there a tectonic plate? Is it one big tectonic plate, or is there lots like Earth? we're going to try and figure that out. And also try and figure out the planet's history. These missions will help answer some of the remaining questions about Venus, including the possibility of active volcanism and the planet's potential for hosting life in the past. Could there be life there before all this happened? Was Venus as far away as Earth was, and was it just like us, and then all this happened? Did something destroy the atmosphere? What made it spin backwards? All these questions still need to be answered, and we still need to learn. Speaking of life, while the surface of Venus is incredibly hostile, sometimes they speculate the possibility of microbiological life existing in the upper layers of the atmosphere where temperature and pressures are more like Earth. This idea gained some attention in 2020s when a controversial discovery of phosphine, a chemical on Earth that is associated with biological process in Venus's atmosphere. While this finding is still debated, it highlights how much we still have to learn about this enigmatic planet. So there could be life in the sky, living in the clouds. Could there? If there is, what sort of life would it be? Is it bacterial? Is it smaller? Microbiology? We don't know. We've got a lot to learn. And we don't know. That's the honest truth. So by going there, we're going to figure it out. We do have a lot of missions coming up. So we need to keep looking to Venus. Because obviously, we've got Venus, that is, if the greenhouse gases trap everything in, and we don't look after the Earth, we're going to end up underwater, and then it's all going to melt away, and then we're going to end up like a barren rock. Or we're going to go the other way, like Mars, a frozen, desolate planet with no magnetic field. So the atmosphere has all been pushed out, there's nothing to keep the atmosphere in, and become a cold rock. Are we going to go one way or the other? As I said, we're in the Goldilocks zone. We are just right where we are. We're perfectly safe. We're not too far away. We're not too close. We're perfect where we are. And we are trying to understand both planets about how to make sure the Earth stays Earth, how to look after it better so we can live longer. That's it for today's episode. The next episode is also going to be about Earth, maybe a little bit longer, so I hope you join me for that. If you have any questions, please use the comment sections and everything. Don't forget, thank you for being part of the Patreon to watch this episode, and I hope you keep enjoying our future episodes. Any questions, please let me know, and I looking forward to you hearing me next time. Take care.